Okay, so we left off with friction. Just remember that a smooth surface has less friction. That's why you slip and fall. Tell you a really funny quick story. When me and my brother were very young and very stupid, we would like to put each other against these challenges. One of our challenges, which I don't recommend doing this, was putting on rollerblades and trying to ice skate whenever it snows. We would skate across the ice like we had on ice skates. Just so you know, you will slip and fall doing that. So I don't recommend it. All right, the next thing we're going to talk about is gravity. Gravity is a force that we know that pulls us to the earth. And the reason for that is because gravity pulls objects together. Like how the moon is pulled to the earth, or like right here with the apple is pulled towards Isaac Newton's head, which is the myth behind gravity and how he discovered it. So the thing about gravity is a pull between objects towards one another. However big something is, like the earth or the moon, the more gravitational pull it has. So that's why the moon orbits around the earth, is because the earth has more gravitational pull, so it pulls the moon around it. When there's more distance between objects, there's less of a pull. So that's why, for example, we don't have like gravitational pull from the moon affecting us. We have our pull from the earth. So if something is bigger or if it's closer together, there's more gravitational pull. This is true for like other objects. For example, like we have gravitational pull for other things. Like I have this cup sitting here, it's pulled towards my table. So gravity is not just holding us down to earth, it is also pulling stuff together. The reason why you don't notice gravity, the gravitational pull for like you and another person, for example, is because we're just not as big as the earth is. The earth is so big that its gravitational pull kind of overrides any of that other gravity that we have. Now, speaking of gravity, as things fall, they encounter another force, which is called air resistance. Basically, it's friction of the air. So if you look at like this leaf, for example, when it falls slowly to the ground because the air underneath it is producing a friction that slows it down. The air resistance is not the same though with other objects like this round acorn. If you've ever seen an acorn fall from a tree, it falls pretty fast. That's because it's not as spread out as this leaf is to catch the air. So if you think about something like a parachute is made to be very wide and to capture a lot of air underneath it. So it can take advantage of that air resistance to slow you down. So that air resistance is there as a friction. It's a type of force. Now, here's the really cool thing. If there was no air, these two objects, the leaf and the acorn, even though the acorn's probably a lot heavier, they would actually fall and hit the ground at the same time if there was no air. And the way that we know this is by the study with gravity that Isaac Newton did, but also when we went to the moon. One of the experiments that was done on the moon was that two objects at two different weights were dropped, and because there's little to no atmosphere on the moon, those two objects, even though they did not weigh the same or have the same mass, they actually hit the ground at the same time. So again, air is what slows things down as they fall through the air. All right, so I want you to think about this. You see this picture here, you see the football player kicking the ball. This ball, as it's being thrown or as it's being kicked, is called a projectile. So this is the projectile motion. what makes the football curve towards the ground like this? What force is acting on it? So if you think about it, gravity is pulling it down towards the ground, and also air resistance is slowing it down. So there's friction of the air. So both of these things make the football, when it lands in that curved motion there that you see. All right, so the last thing that we're going to go over today is Newton's laws of motion. The first law says an object at rest will remain at rest. An object in motion will remain in motion unless there's an unbalanced force that acts on it. So what that means is objects will keep doing whatever they're doing, either they're in motion or they're at rest, until some kind of force acts upon it. So if you think about like the soccer ball, it will stay on the ground and rest until somebody kicks it, until there's an unbalanced force. And here's the really cool part, is that soccer ball, if it wasn't for gravity and for friction, it would just keep going off into space after you kicked it. So it would just keep going and going and going. But since we have friction and since we have gravity, those two forces slow it down and stops the soccer ball after you kick it. Same thing for any other object you can think of, like a basketball. You make a shot, that ball doesn't just keep going into the air because there's gravity and because there's friction that slows it down. So that was the first law that Newton came up with, that objects will keep on doing whatever they're doing. Either they're at rest, they want to stay at rest, or if they're in motion, they will stay in motion until there's a force that acts on it. So this is also proven if you've ever been in a car and somebody slams on the brakes really fast, you notice that your body stays in motion. And the reason for that is because of something called inertia. We resist that change of motion. So for example, the car stopped, but since your body's still in that car, it is stopping, yes, but it also will keep moving some before it stops. So we resist that change in motion, and that's called inertia. You can see that here in this cartoon. Okay, this is Newton's first law. You're in motion until the motorcycle hits the wall and inertia takes you over. Same thing with this picture. Okay, so he understands what I'm saying now. Inertia is that resistance to change. All right, now for the second law of motion. And this is honestly the one that people tend to forget about. What it says is acceleration is produced when a force acts on a mass. The greater the mass of an object being accelerated, the greater amount of force needed to accelerate the object. So what does this mean? Let's break this down. Basically, bigger objects like a bus take more force than something that's smaller. And that's to accelerate it, to speed it up, or to slow it down. So if you think of an example of this one, let's say you see a mystery box in your room, okay? You see that the box is closed off and you go over there to pick it up so you can move it across the room. Well, when you go to pick up the box, you may expect it to weigh a certain amount. So when you go to pick it up, you anticipate it, so that's how much force you use. But come to find out, this box is actually empty. So when you go to pick it up, you pick it up with a lot of force, and then you notice that you don't need that much force to pick it up. So things that have a heavier mass do not take as much force to move versus things that are smaller. So that's what Newton is saying in the second law. So I want you to think of some examples of Newton's second law. All right, so here's a picture to show you what this law means. It would take a lot of force for somebody to try to push something heavy like an elephant. All right, the last of Newton's law, and this is the third one. This is probably the most famous one because it's so catchy to say. It rhymes. For every action, there's an opposite and equal reaction. So if you think of it like this, for every push, there's a pushback. And this is actually how rockets work. Rockets, there's an explosion down here. That's the push that lifts it off the ground. That lift is the reaction. That's the pushback, and that's what causes it to go up in the air. If any of you like to skateboard or play sports, this law is in a lot of different examples with sports. So let's say you're skateboarding and you push with your foot, the reaction moves the skateboard back. So for every push, there's a pushback. If you go to play volleyball, I know I used to play volleyball back in the day. When I would push the ball with my hands, I would feel some pushback, and sometimes I would even get such a strong pushback on my wrist and my arms that I would get bruises from playing volleyball. So for every action, there's an equal and opposite reaction. All right, here's proof of Newton's third law. I thought this was funny. If any of you have ever been hunting with your parents, then you know that guns, when you fire them off, there is a pushback. So the reaction takes place in the gun, and then the reaction or the pushback causes the gun to move back. And if this was to happen in a boat, then the boat would go backwards. All right, the last thing I'm going to go over with you is momentum. Momentum is basically something that has to do with how big something is and how fast it's traveling. For example, momentum, when two cars hit, it transfers, that energy transfers between them, and that momentum can be carried to the next car. And that's why people get like whiplash when they're in the car from an accident. And you can see that here. You can see the momentum with these boxers. This boxer hit that one in the cheek, and you can see the momentum being pushed through his face there. So it's pretty cool. All right, that is motion and forces. Let me know if you have any other questions.